Hey everyone, welcome to another episode of the New Stack Makers, our live stream today. We are discussing fires, alerts. There has to be a better, more boring way. And we know how complex this world has become, especially for those engineers out there who are building out these very scaled out distributed architectures. So to help us parse this and help us understand this world better and how we can build that reliability into our systems and services, I have Madhura Maskasky, co-founder, vice president of product, Platform 9 Systems. Madhura, thank you for joining us.
Thank you for having me.
And Leonid Belkind, co-founder and CTO at StackPulse. Hello, Leonid.
Hey, Alex. It's a pleasure to be here.
It is great to have you here. And we've actually had some fun conversations over the past few weeks today and in a conversation late last year. And we were discussing resilience and reliability and how important that is. And really, essentially, that is like making things boring, but it never really is boring, is it, Leonid? It really depends upon how you prepare yourself and how you think about a lot of the factors that go into what makes a reliable system, what makes a resilient system, so you can have those magical experiences for your end users.
You know, first and foremost, Alex, as a consumer, as a user of lots and lots of software services that I depend on, right, being ordering my lunch or I don't know, having a financial transaction, I'd like to say that, call me old-fashioned, I want it boring. I want my electronic banking to just be there for me and work there when I want it, how I want it, every time, right? If I'd like to find myself excitement and live on the edge, I would prefer to do it in other areas. Now, what it means for the people who are operating this service for me, right, is that I'd like them to avoid being excited, them to avoid running into the situations when, something goes wrong in their production and people are literally looking at each other in amazement and saying, oh my God, we did not plan for that. I really would like this not to happen.
That makes sense to me. Madhura, I wanted to ask you a little bit about SREs, but before I do, I want to let everyone know out there that you have the opportunity to ask questions about how you do make these environments boring. Both Leonid and Madhura are experts in this space. Madhura, I am curious from your perspective on what is the reality now for enterprise engineering groups to achieve resilience and reliability when you're looking at distributed systems that are constantly changing. Who is the SRE now?
Yeah, that's a good question, because if you look at the spectrum of where technology was and what the role of SREs was probably 10 years or 12 years ago, and how it has evolved as the technologies that are used to deploy production applications have evolved from bare metal to VMs to containers. We've gone from more of a traditional role of a system administrator, and I remember my days at Oracle, which is where I worked before working at VMware, before starting Platform 9. There was this dedicated system admin role in a lot of the operations that they performed, at least in the context of database maintenance, used to be extremely manual, right? Which is, taking down database for upgrades or doing certain, schema rollouts or making some config changes. These are all edits or updates that are done through config management systems or change management systems, which had a scheduled downtime, et cetera. And the way the systems and trends have evolved is away from that model, more towards a model where developers are able to push, tens or even hundreds of changes a day, while there being absolutely no downtime for the apps that are running, that are being consumed live in production by end users. Right, so that's how the app, I guess, the lay of the land has evolved, and hence the SRE role has needed to evolve to keep up with that, right? And while that transition has happened, the role has changed from being system administrators to more site reliability engineers, as Google has defined it, right? And the way Google defines it is that an SRE by nature needs to be someone who develops or writes code 50% of the time, and only the remaining 50% of the time they do the traditional ops operations. And this is because they want to do more through automation as part of the role or the requirements of the SRE himself, so that you can run apps that can serve billions of requests, but that are still handled by a few dozens of SREs or etc. So I think that's kind of the trend that has evolved, and I think we can get into specific details of how containers have contributed to it, but I think that's kind of at a high level how I think the trend has evolved.
Yeah, let's break it down a little bit as we go to discuss more about the actual mechanics of it. But before we get to that, Leonid, when you are thinking about these roles that people play, what's happening to this system administrator? Is the system administrator becoming an SRE? Are they going into different roles? Are they taking multiple roles? And how do they play a part in assuring that reliability in these new roles? And then maybe we can go from there into tightly coupled versus loosely coupled systems with Madhura to talk a little bit about kind of the differences and what that means.
So it's actually, it's also an evolving story, right? Because back in the day, there used to be a clear distinction between somebody who develops a system and then system administrators, system operators, etc., right? But as cloud native architectures prevail, as developers, software engineers get more power, right, to deliver more business logic and functionality faster to production with cycles that sometimes takes minutes, right, between the developer's table and the production with fully automated testing, this role of somebody who is responsible for the service being reliable, it cannot stay monolithic, right? There cannot exist a world where person A would be just responsible for building a new functionality, designing something for the users, for the customers, and then an entirely different person just focusing on reliability. Suddenly, the responsibility for SRE gets democratized and gets distributed among different roles, turning the SRE more into an architect, right, that focuses on it, but the implementation itself, what Madhura has pointed out, the fact that today reliability doesn't mean that I'm on call waiting for this, things to go wrong and then manually fixing it. It's developing mechanisms for it to be resilient. That is a responsibility of each and every engineer.
Were there SREs then when people had mostly monolithic environments, when the systems were more tightly coupled? There was so much configuration management required, to actually to upgrade to new versions of a software, for instance. But now, were they SREs back then? And how does the role change with when we have more container-based architectures that are more loosely coupled, where everything is essentially connected?
Mm-hmm. Yeah, I think there were folks who played some or parts of similar roles. They're probably not called SREs. It's probably a relatively more recently coined term. But the role, as you described, was a lot more static, a lot more doing manual operations. As specific examples, before a traditional software got installed, someone, and usually the sysadmins or SREs back then, would need to make sure that the databases are set up properly, which was a role of a distinct database system administrator, that the config files are set up properly, because the applications usually have their database username and passwords that are stored in these config files, but the apps are not responsible for writing that database entry. So someone else needed to make sure that those were pre-populated so that the app can come up and do what it needs to as part of the initial installation process. And then the traditional, dreaded upgrades of these large monolithic apps, which would take anywhere between days to even weeks of downtime if the rollout of the newer version did not go as expected. Right? I mean, I remember times at VMware where, the system administrator, the VMware admin community would try to avoid upgrading to the latest version of the software. And me and my co-founder have talked about this in the past as well. It was very disheartening for us as engineers to see all of that innovation that goes in the most recent version of a software, and then to see the community not that interested in picking it up and upgrading, because they were dreading that whole experience of upgrade so much, because it was such a manual process that would take such a long period of time. Fast forward to now, right? And technology has evolved in a fairly significant way, but especially with the introduction of containers and microservices, I think one of the good things that has happened is certain design patterns have changed, and that have resulted in engineers and developers starting to take more of the responsibility that was taken up by sysadmins in the past, and developers trying to incorporate that and build it into the apps that they're building. So I'd like to give one specific example here. When we at Platform 9, when we rewrote our traditional VM-based stack into containers, one of the explicit steps that my co-founder Bickley, he took is that he made sure that every single microservice comes up with the metadata that it needs that describes its requirements and what other services it's going to talk to. Every service comes up with that data, and then that gets written to a key value pair store at the time when the service comes up. So for example, if it needs access to DB, it will generate a username password, it will write that to a database, and then a DB app will pick that up and create an entry in the database. So this is a way of developers taking that responsibility and writing that as code into the app, which simplifies that part of the responsibility for the SREs. However, in turn, it makes certain other parts of their life complex, which I think we should talk about as next steps. But I think that's how as systems have evolved from being more tightly coupled and monolithic and being in single or a couple of virtual machines to tens or 30 or hundreds of microservices. Some things have shifted towards better, while at the same time, certain complexities have increased.
Yeah, let's talk about how things have changed and what are the challenges now, Leonid. And one of the things I think about is just, the increasing complexity of distributed systems, as we well know. We were talking about that before. And you have, for instance, APIs that are getting overloaded, so it creates bottlenecks. There must be any number of issues. How do you prioritize that? How do you think about these issues? So when you're in a team that is that it has SREs and system administrators and other people.
So in my experience, there's a fundamental difference in approach between, let's call it for a moment, traditional operational approach, something that would be mostly prevalent among communities of traditional system administrators, versus SRE or developers approach. You see, engineer, right, first and foremost, is the kind of person that for every problem they see would try, rather than thinking of a process, like to repeat in order to solve a problem, an engineering state of mind always leads us to, let's invent a mechanism, right, that will solve this problem for us. And then this mechanism can withstand scale, right, because it does not depend on human beings. Therefore, if multiple occurrences of that same problem take place at the same time, well, the mechanism will have to work slightly harder than usual. But then again, it's a mechanism, there is no problem with that. And to your point about prioritizing, about handling the noise that sheer complexity of systems sometimes introduces, I think the key is right here. And we actually see this as a thread, right, that goes through all the development cycles of a modern software, right? As Madhura has pointed out, you don't first develop a software, right, just focusing on what it does, and then you start thinking about how to make it scalable, how to make it resilient, right? The whole point of modern cloud-native infrastructures, abstraction layers that they provide, microservices, service meshes that handle certain issues with APIs, how do components interact, right? It all guides engineers to build systems that would be geared for resilience from, the moment they leave the designer's table, so to speak.
I think I think one of the things that you find here, and I think we may have a freeze a little bit, but are we there?
I'm here.
Great.
Likewise.
Great. Okay, great. And and so when you're talking about the design phase, Leonid, then I'm curious about what it is that the SREs take away from the design phase, and maybe Madhura, you could comment a little bit about how that plays into microservices development, and then how you think about that in terms of how you make those environments boring, because they're just so different now with services requiring their own data store and so on. There's just a lot of complexity there.
Let's begin with a very basic principle that every modern microservice in a production environment today has to comply with. Every modern microservice has to have what we call a health endpoint. What is a health endpoint? It's an API call, if you will, entry point to the service that doesn't necessarily do anything meaningful in terms of the job that the microservice is supposed to deliver, but it runs enough verifications in order to be able to respond to the health orchestrator monitoring system in many cases. Yes, I am healthy and operational. Now think about it. This thing is introduced purely at design and engineering stage. In fact, in many companies, this is a part of a mandatory checklist. You will not be able to deliver the component into production unless it comes paired with this health checkpoint. This is a perfect example of a very early stage preparation, right, for being resilient. Now we can talk about when numerous services, either instances of the same particular service or different interacting services, are now running in a scalable production environment. What happens with an orchestration? What happens if one of them starts responding negatively to this health check, etc., right? This is all about production, but you see the roots of this capability that is key to most cloud native environments begins very much with the development of the first lines of code.
So where does the toil come in, Madhura? Where does it get complicated? Where does it get challenging when you're going from the design table into development and deployment? And where are you seeing the biggest bottlenecks?
Yeah, just one comment on that, the health checks, because I think that's a really good and important point. I think one of the nice things about microservices architecture in the Kubernetes world especially is that most services are designed, as part of the design principle to, again, come up with the ability to publish their health metrics on a regular basis, so that systems like Prometheus, etc., can gather these metrics and, create some reports and charts that end users can expect to view for every service they deploy, whether it's a third-party service or an app that's built by developers within their company through their Grafana dashboards, and which kind of brings a level of standardization to monitoring and metrics consumption and management of microservices, which is really critical because you have such an explosion of scale of microservices that if each one of them were to have its own way of configuring and publishing metrics, etc., that will make the lives of SREs, that much harder. So that's a nice thing. I think the complexities where they come, they're many, right? And they come for the most part because of the fact that what used to be these monolithic services are now broken down into these 30, 40, hundreds of microservices. So again, going to some specific examples, for an app that has been deployed in the form of, say, 30, 40 microservices, each microservice being represented as one or more scaled out pods in the context of Kubernetes. Now, a request comes in, some form of a loosely coupled transactional request that's ultimately going to probably write some data to some data store. But that request needs to make multiple hoops across a disjoint set of microservices, which each is going to perform its own independent task. Right? So if a user is putting in a request to purchase something, the request might first get routed to a data store which has his preferences to give him some recommendations. Then it might get routed to some other transactional components and a whole bunch of other things in the middle. Now, let's say somewhere during this process that request fails, and it could fail for a number of reasons, a networking failure, or one of the pods crashed, or one of the systems had a failure domain going down. Just to debug and triage and figure out where that failure happened in a world of microservices is a very difficult task, right? You need to identify which specific pod out of the 10 pods in a scaled out microservice deployment actually took that request, in order to then log in and look at the logs of that container and figure out what exactly went wrong, or to execute commands like Kubernetes pod describe or a whole bunch of other debugging commands that help you get to that problem. That should kind of give us some perspective into the magnitude of scale and the complexity that has that we've added to the lives of SREs or folks who are responsible for debugging and managing these production systems. And I think another dimension to it, which makes things even more complicated, is the fact that an app could get deployed on premises on your data center today, or the same app simultaneously might have one instance deployed on premise while another scaled out instance deployed in the public cloud, right? Which means there's different kinds of integrations, different native systems that are being used, and that makes the debugging challenge even more complex.
So we're looking at multiple infrastructure environments. We're looking at multiple hops to be able to connect all the services.
Mm-hmm.
We're looking at databases and and what kind of databases you're thinking about and what you're using, because increasingly with distributed systems you may have to install the same instance on multiple regions, right?
Mm-hmm.
So then, what are the ways that we're seeing this being these processes being managed then? So when we think about those challenges, what comes to mind for you about approaches you've seen that have worked effectively? Maybe we could start with Leonid on that and then go back to you, Madhura.
So, first of all, the fact that the more the complexity grows, the more challenge of understanding how it works grows is described by a scientific theory called the systems theory, right? It's sort of like has a very scientific foundation beneath this phenomenon. Now, in order to be able to cope with this complexity, there are two related but still distinct fields that an organization needs to excel at. One is called observability, another is called reliability. Now, sometimes the distinction is not very clear, so let's make that distinction, and I think it will make the discussion around these two very sort of like structured to understand what enables you to do what. So observability is the ability of someone or something external to the system to understand its internal state just by its outputs. Imagine the system as a black box, right? You don't touch it, you cannot open it and look what's inside, but you still need to understand, as Madhura has pointed out, and there are many such boxes, what has happened inside each and every one of them in sort of like the step of processing certain data requests. So your ability to get these things outputted by the microservices themselves and then processed by an observability system to figure it out, that's observability. It helps, but that alone does not ensure the fact that when things go wrong, your system is reliable, right? That needs to be something additional, a whole layer that is built on top of observability, right? If you have a problematic observability, it is very difficult to build a decent reliability because you don't know what's happening. But if you have a top-notch observability, that still does not mean that your system is reliable. It means that it has a potential to become one.
Madhura, would you add anything to that? And then we have a question from the audience that I'd like to pose.
Yeah, no, absolutely. And, Leonard touched on the observability part, which has become a bit of a buzzword, but I think it is probably one of the most critical things to have a good solution for if you have deployed large-scale microservices-based applications in production. And I would, go even one step further and say that, there are many solutions that claim to solve this observability problem today, but they, at best, I think, serve to be different components, different ingredients that are needed as part of a complete solution, but there hasn't really a tool that would very effectively solve the observability problems for end users has not really emerged. Typically what users would do today is they would use a really good log aggregation tool. They'll combine that with a really good monitoring tool, like say your Datadog or your Prometheus and a Cortex-based deployment. And then they will make use of these tools and maybe a service mesh as these three-pronged systems to try to make sense of the environment that you have. But if you look at a day in the life of a typical SRE or an admin or even a developer who's responsible for debugging these live production-based microservices, they'll talk to you about a ton of still, command line, trying to do, like I said, pod describes and getting into the metadata of each individual Kubernetes objects and instances to try to figure out where things failed and what were the causes of these failures. So that's kind of that added dimension to what Leonid was saying, which is observability continues to be an absolutely critical thing, but it's still, for the most part, a massive and unsolved problem today.
So and this was actually a question we just received, is, do SREs need to care about observability, and is observability something that is of interest?
Yeah, I mean, I would answer to that by saying SREs absolutely need to care about observability, right? In fact, if you define the role of SREs as someone who's responsible for the production upkeep and management and maintenance of software that gets deployed, that includes a whole bunch of aspects, right? It includes high availability, it includes performance and latency measurement, etc. And then it includes your typical upgrades and updates. And you could say that some of these upgrades and update operations have been simplified to some extent because Kubernetes and microservices apps have some of these built-in constructs around rolling upgrades and making sure that you deploy upgrade to part of the app and then you monitor it before you roll it out to the entirety of the app. I would say that has made some of the upgrade challenges easier from the perspective of the responsibility of SRE, but conversely, the observability challenge has expanded, and it is absolutely part of the responsibilities of SREs, because it is what you need to do to make sure that a production app continues to stay up and running, and you're able to promise higher SLAs, and you're able to keep up with them. And when failures happen, you're able to diagnose and debug and get to the root cause quickly enough so that you can feed that back to the development teams and learn. I would say, keep an eye in this space, because I think there is going to be a ton of interesting and new observability tools beyond your typical log aggregation and monitoring and your service mesh that are going to evolve, that are going to make the lives of SREs much easier.
So, Leonid, when you hear that and you hear about the traditional roles of system admins, and we just received a question related to this, who's answering the call in the middle of the night? Is it now the SRE, because they're the ones who can look at the, can look at the overall system more effectively, or is the system administrator more the person who does that? How are we seeing change here?
Actually, it's even more complicated than that, quite frankly. So you're right. I mean, the SRE profession got this unfashionable name of people walking around with pagers and being beeped whenever something goes wrong, right? But the truth is that we see more and more organizations actually distributing this load, right? This is, I think, wow, it's encompassing the whole industry. It is very natural for a small, young technological startup to adopt a doctrine where every engineer would actually get calls when they are on call for their particular component and field of responsibility. Recently, for instance, StackPulse being a company active specifically in this field, we see this happening in even largest and traditional organizations, definitely largest technological vendors. Now that goes without saying, but actually think of your banks, your insurance companies. Can't think of anyone more traditional than financial institutions, where they have a lot of software and a lot of services, and even those companies are adopting this new trend of no, there's no more such thing as just the system guys getting the call and all the rest sleeping safe and sound. It's first and foremost, does not reflect well on the efficiency of the service. Distributing the load, making sure that the most suitable person gets to address each and every issue when a person needs to address it, is definitely a trend that we see. And then the point comes where the question is popped about, okay, so now it's not just SRE devoting a certain percentage of their time to being reactive versus proactive. it becomes a question in a day of life of each and every engineer. And this is when I think there is an inflection point for a discussion on how you can sort of like stop being defensive, stop putting off fires, and embark on proactive improvement of your remediation techniques, of your resilience, naturally for the sake of the users of your service, but actually, quite frankly, for the sake of quality of living of your own engineers. That will deteriorate if you don't do it.
So just in conclusion, I wanted to talk a little bit about the concepts of reactive programming and how they've changed. And, we're doing our own research and finding that, asynchronous data streams are becoming popular with SREs and developers, and I'm wondering why. And then I think, basically in conclusion, thinking about what do you see as the dynamic changes that will continue to affect the SRE, and what role will that play in terms of remediating incidents faster and building more reliable services, so we can all be bored and go to the beach, I guess, so to speak. Madhura?
Yeah, so I think what Leonard touched on, it's a very critical aspect of it, which is, if you again do a comparison to traditionally how the roles of developers versus SREs, how the interactions happen, developers wanted to push more and more changes because they wanted to evolve the software, and SREs were change averse, or the system administrators in the traditional world, right? Because change would mean potential for risk of things getting disrupted and disrupt. But we're fast forwarding to today's world, where if you are not pushing changes on a regular basis through some kind of CI/CD system for your live production apps, then you're probably not doing things right? And you're going to find it difficult to stay up with the innovation that your competitors are doing. So the relationship between SREs and developers needs to change to be more collaborative, and one that encourages more changes to be pushed live, while simultaneously there being the right checks and balances that make SREs' lives easier, right? So the one thing that I would encourage all the SRE folks to do is, when you get paged on that, on-call alerts, and when you get, woken up middle of nights or whatnot because of a production crash that happened, it's just as much your responsibility to then next day, after the triaging is done and the fires have been put out, to ask your development counterparts, hey, do you have metrics that are built into your software applications that are catching some of these errors or some of these issues on a routine basis, so you are able to get to these errors before they wake me up in the middle of night, right? Because we're at a point today where there are excellent metrics, measurement, and management softwares that are out there that developers can incorporate as part of the software development lifecycle itself, so that makes the lives of the SREs and folks operating these apps in real time much easier.
So doing error checks and such.
That's right. Yeah. And gathering them on a regular basis, so you start seeing the patterns of errors that your app is running into, which makes it much easier for you to fix them beforehand, or identify problems beforehand before they really cause big outages.
Leonid, bring it home. Let's hear from you about what was just said here about the collaboration, but also about the new thinking about reactive programming and what we think about and this view of asynchronous data streams.
I'll make a prediction, Alex, that is much bolder. You see, I think that the history has a tendency of repeating itself. And if we look at the relatively recent history of evolution of software engineering, we will see a very clear trend, a trend of manual repetitive processes being replaced with automation. When I started my career in the 1990s as a software engineer, I used to have a full team of colleagues that would do manual QA. While these teams still exist, a big chunk of quality assurance testing and gating is done today automatically. Then we had another set of colleagues that would do integration, would produce official builds, would package software, would do digital signature, replaced with continuous integration. Then we had yet another set of colleagues that would schedule those downtimes, as Madhura has pointed out, would deploy upgrades, would roll them back if some problems occurred. Naturally, continuous deployment, and even infrastructure as code has replaced that. So my bold prediction, Alex, is that those trends that you are mentioning will actually lead the industry into the next step of evolution, where SREs will focus on the fact that they are first and foremost engineers that happen to care for reliability and not, say, for user interface or databases, but they're still engineers. And engineers have one way of solving problems, and that's building mechanisms, not only for observing behavior and identifying problematic patterns, which is already taking place today, but actually for fixing them, for making systems self-healing, for making systems more resilient, not as a result of somebody looking at a very elaborate picture and then manually changing the course of action, but actually for having a mechanism do it as a direct result of these sort of like trends that you're mentioning. So if you're looking for the next evolution, in my mind, there is no doubt that it's going to happen right there.
Well, thank you both for taking the time to talk today in this conversation. I've really enjoyed the perspectives that you're bringing here about how you can prevent those fires, how you can prevent those alerts, and how there can be a better, more boring way, so to speak. And this last little bit about that collaboration between SREs and developers is interesting to me and speaks, I think, to where, you know, the dual responsibilities lie, the whole responsibility lies. So I want to thank you both. Madhura Maskasky is co-founder and vice president of products at Platform 9 Systems. Thanks to you for joining us, Madhura.
Thank you. Thanks for having us.
And Leonid Belkind, co-founder and the CTO of StackPulse. Thanks so much for joining us.
Thank you, Alex. It's been a great conversation.
And thank you, everyone out there, for tuning into our live stream. We've been enjoying these live shows. So thanks, everyone, and we'll be back again soon.
Thanks.